It is possible that the biosignature of extraterrestrial life was discovered on K2-18b by the James Webb Telescope. In particular, it discovered signs of dimethyl sulfide, a sulfur chemical that is normally created by living things on Earth. However, how did scientists initially find possible indicators in the exoplanet's atmosphere? Can we now say no to the age-old issue of humanity? Are we truly alone in the universe? Above all, why aren't aliens present if they are indeed out there? In actuality, the last query is not brand new. It explains the straightforward but excruciating central idea of the Fermi paradox, which was proposed by the famous physicist Enrico Fermi in 1950 and addresses the puzzling lack of our alien neighbors. Theoretically, it would appear that the universe has given enough time and celestial bodies to support the growth of innumerable civilizations. However, our cosmic contemporaries are still undiscovered, at least officially, of course. As everyone knows, there are also innumerable videos on the internet that show strange flying objects that are genuinely unreal. Then there are the claims made by people like Bob Lazar and David Grush that the U.S. government has been conducting a covert UFO recovery mission for many years. But for the time being, we should stick to the publicly verified facts before delving too far into the realm of contentious speculation. We Earthlings are the only known life forms in the universe, according to the Voyager Golden Records, and wow. Signals, but with hundreds and thousands of shapes in the starry night sky, isn't that odd? Does the Earth have the potential to be the sole planet in the cosmos to have created life? Many scientists reply categorically no, such as Tom Westby and Christopher Consellis of the University of Nottingham, who concluded in an astrophysics study that 36 highly advanced civilizations might be sleeping in the Milky Way alone. According to the two scientists, the reason they haven't received any attention yet is because of the enormous distances that exist between the various extraterrestrial peoples. After all, on average, 17,000 light-years. To be clear, a light-year is the enormous 9.46 trillion kilometers that light can travel in a vacuum in a single year. Although theoretical astrophysics research is great, aren't there other, more useful methods to address this important subject? Indeed, there are. The James Webb Space Telescope, which has been using infrared technology to probe the universe's innermost secrets for the past 2 years, has repeatedly shown us how skewed our previous knowledge of the cosmos was. As the most potent space telescope ever, Webb was able to detect the heat of a bumblebee on the moon's surface from Earth using the extrasolar water world. However, the telescope, which was created specifically for infrared astronomy, is more interested in providing us with breathtaking views from the depths of space than it is in fat insects. Regards from the Pillars of Creation or the James Webb Deep Field. However, Webb has also discovered a few mysteries since the beginning of its scientific mission in the summer of 2022. This means that it has now found an entire set of early galaxies that go against current cosmology since they seem to be far too big and massive for their time of origin, which was a few 100 million years after the Big Bang. Furthermore, Webb's data could help us better grasp the enigma of the so-called Hubble tension and why the cosmos is expanding faster than our current theories predict. However, we are aware that K2-18b is an exoplanet that is pretty remarkable and can be taken literally. This planet, which is over 125 light-years away from Earth and is part of the constellation Leo, is thought to have a fully formed ocean world. However, because they are only known to exist on paper thus far, these so-called Hycean planets also contain a minor but important catch. Official confirmation in practice is still pending for what is theoretically defined as a habitable exoplanet coated in water. However, the information gathered thus far at least points to the strong possibility that K2-18b could be a moist and livable location. This is due to data gathered by the Hubble, Kepler, and Spitzer space observatories even before the Webb era began, and that data clearly indicates the presence of water vapor in the planet's atmosphere. It is well known that the formation of life akin to that found on Earth is fundamentally dependent upon the presence of water in a permanently liquid state. Furthermore, the foundation for this fundamental habitat is unquestionably in place because K2-18b is located within the habitable zone of its parent system. In this way, liquid water can exist because the exoplanet orbits its host system, the cold dwarf star K2-18, at a distance that permits it. In specifics, K2-18b orbits its star in about 33 days, since the two celestial bodies are just roughly 0.14 astronomical units apart. However, K2-18b receives about the same amount of radiation as Earth, because the star in question generates a lot less heat and energy than our Sun. But when it comes to mass, the disparities are even more pronounced. The exoplanet is referred to as a super-Earth and has 7 to 10 times the mass of our planet. It is important to clarify that this phrase simply relates to the mass of an extrasolar rocky planet, not its habitability, so that we don't misinterpret one another. Does K2-18b harbor extraterrestrial life? Although K2-18b's existence has been known since 2015, we have only recently discovered that its atmosphere includes dimethyl sulfide, or DMS for short. Let's go back to what we discussed at the beginning to see why this discovery might be so revolutionary. On Earth, biological organisms, primarily microbes like phytoplankton, usually create DMS. In addition to acting as a cloud seed and contributing the characteristic maritime smell, DMS is the primary generator of atmospheric sulfur. The principal researchers from the University of California, Riverside, referred to the inclusion of the spectral signatures of carbon dioxide, methane, and DMS in the Webb data obtained with the NIRSPEC, near-infrared spectrometer, as the cherry on the cake. This could be a powerful sign of the presence of extraterrestrial life, if astronomers have indeed been successful in identifying DMS on K2-18b. However, why do scientists continue to exercise careful restraint in spite of all of this? Well, the main reason why the existence of our alien neighbors has not yet been formally declared is that the DMS signal that was captured was not very strong. Moreover, it only became apparent when the specialists conducted a highly particular analysis of the Webb data. The specialists chose to use many models to reconstruct the water planet and its potential biochemistry in order to examine the previously mentioned datasets once more. They modeled the ocean and atmosphere of the alleged planet's spanning environment in these, then examined the amount of DMS that the creatures there would need to generate for it to build up in the natural gas envelope. Simultaneously, the researchers investigated the expected air areas and the rate at which radiation breaks down the DMS. The intriguing finding of this investigation into the origins of life was that on such hydrogen-rich planets, biogenic sulfur gases can indeed build up to detectable levels. The organisms on K2-18b would need to create 20 times as much DMS as those on Earth. Therefore, this would only be feasible if they were noticeably more productive than their terrestrial counterparts. The explanation for this is straightforward. A significant amount of DMS is instantly broken down anew through photochemical breakdown when exposed to infrared radiation alone. On the other hand, the breakdown products of DMS have a protective impact if the concentrations are higher, which would not be unusual for an ocean world. The related chemicals, like methanol or dimethyl disulfide, serve as a sort of barrier for the lower air layers, stopping DMS from further degrading. However, isn't it feasible to obtain a more direct understanding of the actual DMS incidence on K2-18b, independent of such theoretical models? It is, thankfully, but not with Webb's NIRSPEC. This is due to the fact that the methane signal and the DMS signal recorded by NIRSPEC overlapped in a spectral line at 3.4 micrometers. The researchers will thus use Webb's MIRI mid-infrared instrument spectrometer in the future to more clearly distinguish the two chemical values from one another. This operates in the mid-infrared spectrum, which is the exact spectrum in which the DMS and its related products are detected. The scientists hope to uncover the mystery of K2-18b life before the end of this year, barring any unanticipated events. In the near future, we could be able to determine the true meaning of this far-off world's atmospheric signals, which could lead to the possibility that we are not alone in the universe. In order to let us know that we are not alone in the YouTube cosmos, you can now sign our video. To ensure you never miss another video from us, please give it a thumbs up and subscribe. See you soon.